Before we get started with the more advanced examples, let's just take a look at a simple interaction with the many-to-many relationship that exists between items and orders. In this demo, we shall take a look at how we can easily use this relationship to fetch all the items that are contained within an order. We're now inside Visual Studio, and we're looking at the two entities that make up either end of the many-to-many relationship. Here we see the order entity, and here the item entity. As we can see, they look just like they did when we left them the last time that we worked with them. And as we may remember, the many-to-many relationship is implemented directly between the two entities by the two collection properties that we see here. We have the collection of items on the order entity and the collection of orders on the item entity. With a direct many-to-many relationship, adding these two collections is all that we had to do. And then EFCore did the rest of the work for us when we created and applied the code first migrations for this. And now let's head over to the program class in the console application and take a quick look at how we can interact with this. Here we see two bits of code. The first one that we see here fetches the first item from the orders collection on the database context. As we shall soon see, this will not actually fetch anything from the many-to-many relationship. In order for that to happen, we must do as we do here in the second bit of code, where we use the include statement to specify that we want EFCore to also fetch any items that are related to this item. EFCore will do this for us by making a join with the item order join relations table that it has created for us under the covers. And based on that, it will then join to the items table in order to fetch all the relevant items. Let's take a look at this in action by running the code. If we take a step past the first bit of code here, we can see here in the watch view that it fetches the first order for us. But as we can see, if we expand it, the items collection is empty. While this is as we would expect, since we did not use the include statement, let's just head over to the Server Explorer quickly and see that this is actually not the case. Here we see the three tables that are involved in the many-to-many relationship. We have the items table, the orders table, and then finally the item order table that joins the two together. And now let's try to fetch the items from the first order. We can do so by running the SQL statement that we see here. As we can see, what it does is to first join the orders table with the item order table by using the ID of the orders table and the orders ID on the item order table. And it then continues to join with the items table by using the items ID from the item order table and the ID from the items table. Based on this, it fetches the ID from the orders table and the ID from the items table, the name of the order, the description of the item, as well as the quantity of it and its weight and price. And finally, it specifies that we want data for the order with ID 1. The result of this, as we can see here, is two entries, so that is also what we should expect to see if we head back to the program class and move the debugger past the next bit of code here. If we now take a look in the watch view, we can see that we have now once again fetched the first order, but this time the items collection is not empty, and if we expand it, we can see that we get two entries back, just like we would expect. In this demo, we shall take a look at how we can interact with the join entity that EFCore creates for us when we create a direct many-to-many relationship by using skip navigations. We are now inside Visual Studio, and we are looking at the program class of our console application. This demo will be all about interacting with the join entities that EFCore has set up for us under the covers, so we won't actually be changing anything in our data model, just interacting with what is already there. The first bit of code that we see here simply fetches all the items that are contained in the order with ID 1. We do this because it allows us to compare with the data that we will later fetch using the property bags that EFCore has created for us. The second bit of code that we see here fetches all the skip navigations that exist on the order entity. We do so by accessing the entity type property on the orders database set on the database context. This returns to us the type of the entities that are contained within the set. We then call the getSkipNavigations method on the returned entity type, which will return to us information about all the skip navigations that are defined on this type. In our case, we've only defined one skip navigation property on the orders entity. That is the items property, and in the next bit of code that we see here, we fetch the information for that specific navigation from the collection returned to us. Since we know that we've only defined one skip navigation, we could have simply returned the first item from the collection. But the Lambda query that we see here shows how we can fetch it explicitly by name. In the next bit of code that we see here, we fetch all the property bag entities. This corresponds to the contents of the item order table. These entities, which are all of the type dictionary of string and object, each correspond to a single entry in that table. Because we haven't explicitly defined a join entity for our skip navigations, EFCore has mapped the contents of the item order table to these property bag entities. We fetch these property bag entities by using the set method on the database context. passing in the type signature of the property bag entities as the generic input parameter. This is not a database set that we've defined ourselves on the CarvedRock database context, but it exists nonetheless. That is because IFCore created it for us when it set up the direct many-to-many relationship. Notice that we pass in the name of the item skip navigation. Doing so calls an overload of the set method that is specifically used to fetch database sets containing share type entities. And as we may remember from the module where we talked about indexer properties and property bags, this is exactly how a property bag entity is set up. Remember when we created the property bag entity for the tag entity? We did so like we see here by setting up the tag entity as a share type entity called tag, to which we added all the relevant properties, and then we explicitly added a database set to contain all instances of the tag entity. All of this is also in place for our relationship between items and orders, except that we don't see it in our code since IFCore has done all the hard work for us behind the scenes. So by passing in the name of the skip navigation, in this case items, we get back a set containing instances of the shared type entity that IFCore created for us when it mapped the item order table. Now let's try to run the code. If we start by stepping past the first bit of code here, we can take a look at the items that were returned here in the watch view. As we can see, we get 2 items back. If we expand the first one, we can see that it is the item with the ID 1, and if we expand the second one, we can see that it is the item with the ID 2. If we now take one more step with the debugger, we get back the list of all the skip navigations which we can see here in the watch view. As already discussed, we get back only one, and if we expand it, we can see a bit of information about it. First, we can see that it was declared on the order type, which makes a lot of sense since that's where we got it from. And secondly, we can see that the target entity type is the item type. This also makes a lot of sense, since the items collection on the order class is a collection of the type item. We can also see that the skip navigation has been named items, which is a fact that we use in the next bit of code where we fetch that particular skip navigation by its name. If we take a couple more steps with the debugger, we first fetch the item skip navigation, and then we fetch all the property bag entities from the property bag set, which will contain all entries that are stored in the item order table. If we now take a look at the item orders collection in the watch view, we can see that we get 5 entries back. If we expand the first entry, we can see that it contains 2 dictionary entries. If we expand each of them, we can see that the first one has the key items ID and the value 1, and that the second one has the key orders ID and the value 1. This corresponds to the first row in the item order table. And if we head over to the Server Explorer and take a look at the contents of that table, we can see that the first row indeed has items ID 1 and orders ID 1. And we can also see that it contains 5 rows of data, which fits the number of entities that we got back when we created our set. If we head back to the watch view and expand the second entry, we can see that it has the items ID 2 and orders ID 1, which also fits with what we just saw in the database. Now that we've had a look at how we can interact with the join entity that IFCore has created for our many-to-many relationship, let's take a look at how we can augment this join entity by adding a payload to it. We can do so by creating a C# class to contain the data contained in this payload, as well as the items ID and orders ID that already exist on the join table and are used to facilitate the many-to-many relationship. A payload is basically any property or collection of properties that we add to the join entity in addition to the 2 foreign keys just mentioned. IFCore offers support for adding such additional properties to the join entity by allowing us to create a specific join entity that we can augment with the extra data. Doing so is known as giving the join entity a payload, hence the name Skip Navigations with Payload. After having created such a class, we simply need to change how the relationship between our item and order entities are set up in the CarvedRock database context. Such an implementation of our Skip Navigations is called Skip Navigations with Payload, and it is often used to add columns containing database-defined default values to the join table, but as we shall soon see, it can also be used to add other data. Because in our case, we'll use such a payload to overcome the inherent flaw in how we've set up the relationship between items and orders, which means that a customer can currently only purchase one instance of each individual type of item in a single order. This is not a restriction that C# creates for us. Our C# collection could easily contain several instances of the same type, but in the database we'll be forced to create a mapping between a specific order and a specific item based on the IDs of these instances. Since such a mapping in our item order table has to be unique, any given order can only point to the same item once. But by introducing an entity class to map our join entity to, we're able to not only add default values to the join table, but also, for example, add a quantity value which we can use to track how many instances of a given item are purchased in a given order. Previously, when we were working with Entity Framework 6, before EF-Core was introduced, augmenting our join entity in this way would require us to completely rewire our application to use the join entity directly in all the code that interacted with our skip navigation. With EF-Core, the join entity can be configured with payload while still leaving the many-to-many relationship intact. This means that existing code that does not care about the quantity or any other data contained in the payload does not need to deal with the new join entity and can continue to use the skip navigation as if the join entity never existed. That means that we'll only have to change our code in those places where we need to interact directly with the payload. Those parts of the code must be updated to use the join entity, since that is how we can access the data in the payload.